Okay, hello students. Today we'll be starting the new chapter, that is areas related to circles, right? So this is actually the part of the chapter mensuration which you have already done in your previous classes, right? Class 9, class 8, but that was slightly different. This chapter is related to areas of plane figures. Is it clear? Areas of plane figures. So first of all, I'll give you what are the formulas required, the formula required in this chapter. Clear? Some are very basic, some may be new to you. So first of all, we need to understand for circle. For circle, what is the area? Area is equal to what? Pi r square, where r is what? The radius of the circle. R is the radius of the circle. And then what is circumference? Circumference is equal to 2 pi r. Now circumference means it is the length of the boundary, right? Circumference means what? It is the length of the boundary, right? Then comes rectangle. This is the length and this is the breadth. Length and breadth. What is the area? Area is equal to length into breadth, and perimeter is equal to 2 into length plus breadth, right? 2 into length plus breadth means what? This is also length, this is also breadth, right? So the total, in the total perimeter we have two lengths and two breadths. Then comes square. Square, a quadrilateral with all the four sides equal. So let us mark the sides of the square as A. So what is the area? Area is equal to side square, and perimeter is equal to 4 into side, right? Perimeter is equal to 4 into sides because the length of all the sides are equal. Then the next one is area of equilateral triangle. Area of equilateral triangle. This is equal to root over 3 by 4 into side square. Now equilateral triangle means what? All the sides are equal, right? All the sides are equal. That's called as equilateral triangle. Then we can have another formula for area of triangle. Like if the base and the height, right? If the base and the height of the triangle is given, then we can use the formula that is half into base into height. This is half into base into height of any triangle, okay? Let's say this is the triangle, this is the base, and from here when you draw the perpendicular, this becomes the height. There is one more formula to calculate the area of triangle. Which formula? Heron's formula, which we have already done in the previous chapter. So area of triangle using Heron's formula. So in this Heron's formula, see, the length of the sides has to be given, right? The length of all the sides of the triangle has to be given. So we'll take this length of the sides as what? A, B and C. A, B and C. So we'll find out semi-perimeter. S means what? Semi-perimeter. That is half the perimeter. Which is how much? What is it? A plus B plus C divided by 2. And then comes area of triangle ABC. We'll mark this triangle as A, or to avoid confusion, we'll mark it as PQR. This is PQR because we have already used ABC, right? So area of triangle PQR, this will be equal to root over S into S minus A, S minus B and S minus C. Fine. So these are some of the formula. Then I'll give you some more. Okay, next is area of sector, segments, then length of arc. Okay, so we'll see one by one. Sector. See, if you draw these two radii, right? If you draw these two radii, right? We'll mark this as AB. Then it is enclosing. I mean, the circle is divided into two parts. When you draw these two radii, you can see here. Each part is called as a sector. Each part is called as a sector. Now, if I ask you which one is the minor sector, the angles, if the angle subtended by the sector at the center, I'm marking it as theta. If this angle is less than 180 degree, less than 180 degree, then it is called minor sector. It's called what? Minor sector. So this is what? Minor sector. And this angle, right? This angle is more than 180 degrees. So it will be called as major sector. Right? It's called as what? Major sector. So what is the, okay, I'll write it here. Area of minor sector. See, out of this total, the full circle, right? The full circle, we are just taking this part only, small part. That's the minor sector, right? So, how will find the area of this minor sector? It's very simple. It is theta by 360 into pi r square. Right? We are taking only theta. Only this part we are taking out of 360 degree. Total angle is 360 degree. And what is pi r square? Area of circle. Finished. Clear? But I'll not use this term minor, okay? I'll just write down area of sector. I'll write here area of sector. Because if it is minor sector, you'll use this theta. If it is major sector, then use the remaining theta, remaining angle. Any doubt? No, sir. Okay. Then comes segment. Segment is formed when you draw a chord. Right? When you draw a chord of a circle, then the circle gets divided into two parts. Right? If the chord is making an angle less than 180 degree at the center, this angle, less than 180 degree, then this portion, right? The chord is dividing the circle into two parts. Again, I'm telling you, right? If this chord is making an angle less than 180 degree, then this portion will be called as what? Minor segment. And the remaining part is what? Major. It is the major segment. Now, how can we find the area of the minor segment? Very simple. From the area of minor sector, we'll subtract the area of triangle AOB. Right? From the area of this minor sector, we'll subtract the area of this triangle AOB. Okay. So, area of minor segment, this is equal to area of circle minus area of triangle AOB. Right? Area of triangle AOB. Clear? Likewise, if you have to find the area of major segment, area of major segment. See, if we have already got the area of minor segment, right? I'm saying if we have got the area of minor segment, then area of major segment will be what? Area of triangle, sorry, circle minus area of minor segment. Very simple. This is equal to area of circle minus area of minor segment. Okay, but what if the minor segment is not known? Suppose in the question it's not asked to find the area of minor segment. So in that case, how can we find the area of the major segment? Right? There is another way also finding. In that case, what we'll do? See, this portion, right? This portion is called what? Sector. Major sector. It's called as what? Major sector. And this is the triangle. So area of the major segment will be area of major sector plus area of triangle. I'm giving you both the formula, right? Reason, you use the formula as per the convenience. What information is given in the question? Which all answers we have already calculated. Accordingly, you have to use it to save time. Clear or not clear? So, area of major segment is equal to area of major sector plus area of triangle AOB. Correct? Then comes the length of arc. Length of arc. Now, what is this arc? Length of arc. Arc means it's a part of the circumference of the circle. Let's say this is the circle, right? And this is what? This is the minor arc. Now, hope you understood now what is minor arc. If the arc is making an angle less than 180 degree at the center, it is called as what? Minor arc. Okay. So, let's say this is theta. So, length of arc is equal to pi r theta. Okay, let me tell you here also. This will be theta by 360 into 2 pi r. What is 2 pi r? Circumference of the circle. And out of the entire circumference of the circle, we are just calculating the length of AB, which is a part of the circumference of the circle. And this AB is making theta at the center. This theta is out of how much angle? Altogether 360. So this is theta upon 360 into 2 pi r. We'll simplify this. 2 into 1, 2 into 180. So this will be theta by 180 into pi r. Clear? If you have to find the length of major arc, then you have to take the other theta. Is it clear? This theta you have to take it. Then comes area of ring. Area of ring. What is ring? When you have two concentric circles. Concentric circle means circles having the common center, right? Circles having common center is called concentric circle. Okay, let me draw this. These are two circles having radius small r and this is capital R. The area between these two circles, right? The area between the two circles, this is called what? Ring. Okay. So how can we find the area of this ring? Very simple. From the area of outer circle, we'll subtract the area of inner circle. Okay. So this is equal to pi capital R square minus small r square. See, when you open the bracket, what you are getting? Pi capital R square minus pi small r square. That is area of outer circle minus area of inner circle. Is it clear? Any doubt? Sure? Okay. Then one more thing. area of quadrant, area of quadrant. Quadrant means what? Quadrant, quarter circle. One fourth of a circle is called what? Quadrant. Okay. So let's say this is a circle and you have drawn two perpendicular diameters. Remember, two perpendicular diameters. Then each part is called as what? Quadrant. This will be 90-degree and this is called what? Quadrant. So area of circle, area of quadrant will be pi r square upon 4. One fourth of a circle, right? Area one fourth of the circle is called a quadrant. Clear? Okay.